Agile and specifically how to use code reviews in an Agile development environment. So things that we will cover here is what is code review, why should we review code, how to most effectively review code, when in the development cycle should we review code. I'm going to try to demo some code reviewing tools and then share some personal experiences and tips. So first of all, what is code review? Well, it's simply manually reading code with the intent of finding errors and potential improvements. So why should we review code? Instead of answering that, I will give you a counter question. What is the most expensive bug? Well, if we're talking about the most expensive bug in the history of mankind, we definitely have a candidate in the rounding bug that made the first Ariane 5 flight explode shortly after start. And we have the runner-up, the NASA Mars satellite, where different teams were using the metric system and the imperial system, and it didn't quite cooperate. So in this case, I think it was at least 370 million US dollars. Some say up to 500 million US dollars. So fortunately, most of us aren't working on space rockets and these kinds of numbers that may be lost when we're doing something wrong. But we can still learn something from these examples. So which is the most expensive bug then? It's the bug that is put into production and found by the end user. And there are some guys at Hewlett-Packard that have estimated that it actually costs 100 times more to fix a bug after it has been released than if you had found it during a code review. And that number excludes any bad will or any lost businesses that could be the cause of the bug affecting the end users. So let me give you a few examples of this. They had a team of 10 developers that were given 3 months to develop an application of about 10,000 lines of code. And then after those 3 months, they tracked the number of bugs that were found by end users and the QA team for 6 months. And then they had another team of developers review the, so to speak, the original code that was produced after the 3 months before the bug fixes. So they reviewed the code and fixed the bugs that were found, and they did QAing of the reviewed code. So they compared these two versions of the project. And when they did no code review, after 6 months, they had discovered 269 bugs. But for the version that they did code review on, after 6 months, they had uncovered 431 bugs. So they actually found 162 bugs that after 6 months on the other version were still uncovered. And then the manager comes in and asks, well, then what did all of this cost? And it actually turned out that it was roughly 30% cheaper to do it this way. And something that should also be mentioned is that during the review process, they also uncovered a number of flaws in the design of the software. So does this actually work? Well, some more examples. At AT&T, they had a group of 200 people, and they introduced code reviews, and they were able to decrease the number of bugs by 90%. And they measured that they became 14% more effective. And Aetna, an insurance company, they estimated that they were able to uncover 82% of errors during the code review, and they lowered their costs by 20%. They did a test on another group of developers. The same group of developers were given the assignment first to write 5 applications without doing any code review. And after that, they estimated that there were 4.5 errors per 100 lines of code. And then they were assigned to develop 6 other applications using code review. And after that, they were able to find 0.82 errors per 100 lines of code. So that means that over 80% of the errors were eliminated through the code review process. In a maintenance organization, they found that 55% of one-line changes were in error. And I think that number in itself is food for thought. So if you're just changing one line, then think to yourself, I probably got it wrong, right? But then they introduced code review, and they were able to get that number down to 2% for the one-line changes. So let's get back to the question, why should we be doing code reviews? Well, if you still can't answer that, maybe I should talk to your boss. But just to summarize, we want to find bugs early because that will save time and that will save money. And in case you don't care about that and you don't care what your boss thinks, then maybe you care about that in the process you will also become a better developer. And I think you do care about that because you are on this conference to become a better developer. All right, so this code review thing, shouldn't this be something that's an obvious part of any software development process? Much like proofreading of books. Do you think there's any book publisher with any self-respect that doesn't proofread the books before they are published? Well, I think we all know have a couple of books back at home that we wonder, did anyone really proofread this one? There's so many errors. But then on the other hand, what do you think that book would have looked like if they didn't proofread it? So often with software, we are quite good at cooperating during the requirements and design phase because someone argues, oh, it's so expensive if we get things wrong in the beginning. But at the same time, there are statistics showing that most of the errors are introduced during the coding phase of a software project. So sometimes it seems that us as developers avoid code review because we think it's a boring and lengthy process. And my hope for this talk today is to inspire you to think more positively about code review and to do more code reviews and to do them more effectively. So let's stop for a while and compare code reviews to test-driven development, another means of improving software quality that there's been a lot of talk about. The other side now, and people start arguing, is it maintaining all the test cases and so on. And there haven't been much talk about code reviews previously, and I'm happy to see that that's starting to change. I was at Java Zone in Oslo last week, and there were actually 2 separate talks on code reviews, and not including this one. And also in a 2014 survey they did, of the respondents, 35% said that they thought code review was the #1 thing you could do in your development process to improve code quality, which was ahead of both unit testing and manual testing. And this is not just a subjective experience, but there's also statistics showing that using unit tests, you can probably uncover somewhere around 25% of your bugs. And with code review, the average would be somewhere between 55 and 60%. But as we saw in the previous examples, if you're lucky, you can get up to 80 or 90. Maybe, I'm not really sure if you're lucky, maybe you had too many errors in the first place if you get those numbers. Anyway, I do admit it's a bit of comparing apples and oranges. I don't really want to put test-driven development and code reviews against each other. I think they fill somewhat different purposes. So I would say that code review has its best place when you're developing new functionality, where you're adding features, adding stuff to a system that's totally new, and someone should check that new code and make sure that it does what it's intended without any errors. And that will also help you to get easily maintainable code, because knowledge is shared within the team, and you also get feedback on how you can make the code more readable, which can avoid defects later on. It can avoid someone introducing a bug when they are maintaining your code. Test-driven development, on the other hand, well, it changes the way you work with the red-green refactor working strategy, and it can also help you minimize regression bugs. So it's great when you're changing existing code. Though there are some problems with JUnit testing, it can be quite expensive if you have very complex code. There's something that's called cyclomatic complexity. It's a measurement of how complex your code is, and it actually measures the number of different execution paths through a method. And the recommendation is to try to keep the cyclomatic complexity under 10. And if you're up at 100, you can consider that method to be untestable. And as an example, in the Apache HTTPD web server, a couple of versions back, there was a very core function in there that had a cyclomatic complexity of 725, which means that if you should properly unit test that code, you would have needed at least 725 test cases. So a bit hard to maintain, maybe. And then we also have manual testing, which I think we should also have. And it's not least great to uncover like conceptual bugs, things that aren't really coding errors or technical errors, but hey, here's this pop-up and there's no save button in here, so I can't really do the task that I wanted to do within this pop-up. That could be harder to capture with a JUnit test. So the conclusion here is, of course, that we need all three of them. They complement each other. So when we're focusing on code review, there are a number of different types of code review. And the first one is called formal reviews. And there was a guy named Michael Fagan. I think he published a book back in 1976. And he introduced something that's also called formal inspection, or from this guy's name then, Fagan inspection. And it's an interesting process with quite strict forms. The author of the code will collect the material to be reviewed and send it out to a number of people, usually between 3 and 6 people, and also call to a review meeting. Then these 3 to 6 persons, they will study the materials, and then they will attend this meeting, and there's a moderator that organizes things, and they take turns. So the people that have reviewed the code will read out loud their interpretation of the code, and the other people in the meeting will try to spot any errors, either in the interpretation of the reader or in the actual code. And once they have collected all the feedback, the author will go back and make the changes and then send out the material and call to a new meeting. And as you've probably figured out, this isn't really an agile process. There, however, are some agile alternatives to doing code reviews. So, for example, you may have tried pair programming, which could actually be seen as a type of code review. There are 2 people at the computer, one person is typing, and the other one is simultaneously reviewing and making sure he doesn't type any errors. And it's a great way for knowledge transfer. You can discuss the solutions while you are creating them, but it's also quite costly because there are 2 persons there the entire time. So there are some other alternatives. For example, we have something that could be called over-the-shoulder review. So when you are done with your little change, then you go ask your colleague, hey, can you come and look at my code before I commit this to our master branch? Yeah, sure. And you will him or her through the process. And you could also do email reviews or patch reviews. Before there was GitHub and pull request, this was quite common in the open source world, that you created a patch that you sent on to some mail list, and then people on the mail list would provide feedback saying, hey, you need to change this or this, and then at some stage they would incorporate your patch into the system. And then there's also the case of tool-assisted code reviews. There are specific tools created for code reviews that we are going to look at later on. And in the case of these Agile processes, you can make them interactive in most of the cases. So even if you're not doing pair programming, you can do like remote over the shoulder. You can have a Skype or Hangout session and you can talk things through. But I'm not really sure I want to encourage to have interactive sessions, because if you are there to explain your code, it means that you may leave the code less readable, less self-explanatory than had the reviewer just studied your code without you to answer the questions for him. Also, of course, the email and tool-assisted versions, they can also be done even if you're separated geographically and in different time zones. You can do them in different times of the day, and that's great for distributed teams. In all of these cases, it's a good idea to do static code analysis first. So you should let the computers catch what they can before you spend any manual time. That's something you can't do in the pair programming example, because the person is there all the time. Also, in the case of the last three review processes, you can have multiple reviewers. So you can send out the patch via email to multiple persons, or you can invite multiple reviewers into the tool-assisted code review process. You actually can do that also in pair programming, but then it's called mob programming. It's something that's come up recently. So the whole team is gathered in front of one computer and one person is typing. Not sure how many managers were actually allowed to spend that much time producing that little code, if I put it like that, even though it's probably quite high quality code. It's often hard to defend using formal reviews because it's so costly in comparison to the others. Usually you need to work with something like hardware programming or something that's shipped to the customer, and you can't really update it easily to actually be able to defend using formal reviews. And it has also turned out that during formal reviews, most of the bugs are actually found during the preparation rather than during the review meeting. And one of the advantages then of the formal reviews is that during the review meeting, you can uncover any false positives. So if someone says, oh, I think there's a bug here, then the others can explain to him, no, there isn't, because this and this. So you can eliminate that problem. But then I think, well, is that really a false positive? If the code was so ambiguous and unclear that someone thought there was a bug, maybe it should have been changed anyway to make it more readable. And that's why often when you talk about code reviews, you shouldn't be talking about bugs that are explicitly something that's wrong now, but you can talk about, for example, defects, something that makes the code less than perfect. It could be a bug, but it could also be that it's hard to maintain. There are some positive side effects to reviewing code. First of all, just knowing that you will be reviewed and the preparations you go through when asking someone to review leads to better code itself. So sometimes you might do some ugly hack and oh, nobody will notice, and then you just shuffle that into the system. But if you know, okay, this is going to be reviewed by someone, they are going to ask me to change it, I better do it the right way from the beginning, and you fix it. And this is actually true even if you're just doing random samples. So just knowing that someone might review your code makes you improve the quality of your code. It's a little bit like financial bookkeeping and the auditing process. Just knowing that, well, someone might audit this bookkeeping, so I better get it right from the beginning, so no one blames me for any errors in there. And also, it can happen while you are preparing for the review. You're collecting the materials, maybe you created the patch, or You created the pull request in GitHub, and then when browsing through your code, before sending it to the actual reviewer, you notice a couple of errors yourself. Oh, that shouldn't be part of this feature or something like that. It's also, as mentioned, a great tool for knowledge transfer, and this goes in both directions. So both by getting feedback from others on your code will improve you as a coder, and also by reading other people's code will make you a better developer. And this is a great way to introduce new team members. So you can give them the introduction, and then you can let them start hacking on the system, but let everything they produce go through a code review process. And then from there you can teach them, oh, you should have reused this method that's already there for this purpose, or no, it seems you misunderstood this concept, and so forth. So as mentioned, you become a better developer both by reviewing other people's code and having your code reviewed. So when in the development cycle should we review code? After successful compilations, and that may seem obvious, but I say that for reasons of experience. And as I also mentioned, if you're using any static code analysis, and you should be, then do the code reviews after. It's most efficient to let the computers find the automated things like possible null pointer exceptions and maybe formatting stuff and things like that. You should probably have a discussion with your team whether you should do the reviews before you commit or push or merge or whatever your version control system setup looks like. And you could also have a discussion if you're going to do testing of the implementation and possible manual debugging before or after the review. I think some guys estimated that reviewing the code is 20 times more efficient than trying to debug the code manually. So instead of you finding the errors while you are testing stuff and then debugging to find it, maybe just ask your colleague to read it, and it might be obvious to him what you've done wrong. Another thing to consider is whether to review test cases before you actually implement them. So if you're doing test-driven development, maybe you should do some high-level test cases that reflects the specification or the requirements of what you're implementing, and have them reviewed to make sure that, well, if these test cases pass, then yes, the feature has been implemented. So some metrics if you're doing code reviews, and I'm personally not very interested in metrics, but some people are, and there are a couple of them that can be used for the code review process. So we have some basic numbers, which are lines of codes that are under review, and we have the time that has been spent reviewing, and we have the number of defects found. And from there we can calculate speed of the review process, so the number of lines of code that have been reviewed per hour. We can see the number of defects uncovered per hour, and we can get the density with the number of defects per line of code. And something to remember here, that there are multiple factors affecting all of these metrics. So for example, it differs depending on who's the author, who's the reviewer, what language has been used in the implementation, what's the domain, etc., etc. They say that if you're doing a thorough review, you might get like 100 or 200 lines of code per hour. Regular review, maybe 200 to 500 lines of code per hour. And if you're just doing a sloppy review, maybe 800 to 1,000 lines of code per hour. Something to remember when we're talking about metrics that's very important is that you should not use these metrics to evaluate any team members. So you shouldn't judge any reviewers on the amount of time spent or the amount of defects found per hour or something, and you shouldn't judge any developers for the number of bugs per lines of code and so on and so forth. Because as mentioned, it's very hard to actually compare these numbers. So if you have someone in your team that's more senior, then maybe he's the one that's working on the hardest part of the code. Most projects have this little corner in there, oh, that's really tricky, we better not touch that. So if that has to be a change in there, well, put the senior guy on that. So since he's working on the hardest part of the code, that makes it more likely for him to create any defects, which doesn't make him a worse programmer than the rest of the team, even though there might be more defects per line of code of his. So what we need to focus on here is not to evaluate team members, but to create a better product. How then should we do the code reviews? Well, the experts say that we should try to review a maximum of between 200 and 400 lines of code per occasion when we do code reviews. And we should try to do it at a speed of between 300 and 500 lines of code per hour. They suggest that we spend a maximum of 1 hour per day on code reviews. I might get back on that later on. And the conclusion anyway is that the more time that is allowed to code review, the more defects we will be able to uncover in the process. And something else that could be recommended is to use a checklist of things that a reviewer should check for while doing reviews. So is there documentation, is there unit cases, are parameters checked, and so on and so forth. Could be a list that should be gone through by the reviewer while doing the review process. So in case you're not doing code reviews at all today, some tips for getting started is, well, maybe you should just introduce it as something another way to introduce it is some other conditions. It could be mandatory, so has to be reviewed. Uh, 10 plus years ago. So anytime I updated my local sandbox from our CVS server, I had to check what have the other people been up to in the project. And it happened once in a while that I spotted some errors. Oh, this is wrong. Oh, I better fix that. So I made the change and I committed it back to CVS. But rather soon it dawned on me that it's not really a good idea to fix other people's problem without making them aware, because then they can't learn and they keep making the same errors over and over. So when I found something, I started to send my colleagues an email. Hey, I happened to notice this change of yours, and there can be a null pointer exception in here. So you better change that. And that continued for a while, and the team manager caught up on what was going on, and he thought that there's no real good follow-up. You're just sending emails out, and then there's no one really checking if things have been fixed or not. So we better put this somewhere where also management can follow up on what has been done. And well, since it was introduced by management, it wasn't Excel, but by all means Word. So we started with, oh, look here, it looks like a bug. So I copied and pasted from the CVS diff log into a Word document and typed some comments there, and then they fixed it and checked it in, and I checked it again and updated the Word document, and so on and so forth. Which wasn't really great either. So somewhere around 2007, we started to evaluating a separate code review tool. And I thought I would give you a little demo just shortly. And nowadays, code reviews are an obvious part of our process. We have a separate swim lane in our Scrum board, so it needs to pass through this review lane on its way to done. And let's get on with some demoing. So back when we started, there wasn't that many code review tools available. In recent years, there are many big players that have introduced code review tools, and I'm going to mention some at the end, and you will be able to find some links to them. But something that really changed all of this is the introduction of GitHub and their pull requests. And I know many teams do use GitHub pull requests for code review. Personally, I don't think they're really adequate, again, for the follow-up part. So I don't personally recommend settling for the GitHub pull request. Yes, they are much better than not doing any code reviews at all, but I do recommend using a real tool. But just to give you an example, if you haven't used GitHub and if you haven't created any pull requests, just a quick example. So we will create a pull request, and I have some start branch to master, and we will create our new pull request, fix bugs, create. And then in here we can get a diff view of things that have changed, and we can put in comments here. Well, okay, so this was the update of the thing, but let's say we need some documentation here, for example. And then the author can also get in here and chime in with his or her comment, and we can continue the discussion. But as mentioned, it's quite hard to follow up what has really been fixed and what is still an ongoing discussion, and so on. So I'm going to show you one version of the tool that my team is currently using. And it's a little bit different than the one we're having, but let's see if we can, sorry. So I will upload this first one. Example review. So I'm creating from inside my ID, I'm creating a review in our review tool. And then I can go to the tool, and I'm logged in as Charles, the coder. And in here I can assign myself as author of the review, and then I will look up my colleague Ronald, the reviewer, and add him as a reviewer. And after that's done, I click begin review. And then in my other browser window, I'm logged in as Ronald, the reviewer. So I get an email asking me to, hey, click here to review this code, and I can log in. And I can see the list of files that have been changed. So I open one of them, and then I can add some comment. Is this really a good name? And then I see here we can get a null pointer exception. And in that case, I can add that as a defect. So this means that this is not only a regular conversation, but it's actually marked as a defect. So now it's impossible to finish this review before we have followed up and actually marked this as fixed. And when this has been fixed, so I think I can do something like this. I can upload my changes to the review, and then Ronald, the reviewer, can
all this clicking around with uploading stuff, is that do you review against the Git repository How do you?
In this tool, there's no connection to the Git repository. This is a standalone tool, so you upload everything to the tool from your local environment.
From idea, you upload a set of files that you need to have reviewed.
Yes, you upload it from your computer to the tool, yes. So now Ronald Reviewer can see that things have changed. I thought I had side-by-side diff here, but you can change how you want to look at it. And I can mark this potential null pointer exception as fixed. And now the review is good and we can close it and continue. So as another example here, we can use another tool. I think in this case I should look here. And then I can upload this to UpSource. And I will create a review. And I think I'm logged in as Ronald the reviewer in here. In this case, however, we are connected to the GitHub repository directly inside the tool. Let's see if I remember if we can assign reviewers. No, it's already closed. I think we need to do a little bit of tricking here. Example, review. I should have practiced more on this demoing since it's not the tool that I'm usually using. Example, review, and then we're adding reviewer, Ronald the reviewer. And there we go. And then we can go over to the tool. And once again, we can look at the changes. And I can write some comments. Please change the name. And I can also add tags that mark that there are bugs. So if I add the comment, then or label, so I add this bug label. The nice thing about this tool is that it integrates into the development environment. So as you see here, there are some small icons. So I can click that one and I can actually see the comments made by the reviewer straight in my ID. So please change this name, and here's the risk of an NP. And there are, for different tools, there are different plugins to different IDs. So in some of them you can also see that there are actually defects rather than just comments and so on. So I encourage you to try out a different tools and see what suits your team best. So we will get back to the presentation and to some advice of mine from reviewing. First of all, if you're not doing code reviews currently and you want to start doing it, don't get the idea that, well, let's first review everything we've got first. You will just hate code review after trying to do that and not be doing it anymore. So start with a clean slate and say, okay, from here on we can do code reviews. And if you're not having any kind of coding guideline currently within your team, you probably will want to create one. And if you have one, it's quite likely that you want to expand it and make it more explicit, because when you start reviewing other team members' code and you realize that, hey, I may be the one that needs to maintain this in 6 months from now, then you may start get a little bit picky. And it's good to have agreed beforehand on what things should look like, how, so to speak, how wrong does something need to be to actually be fixed, and so forth. And as mentioned, this is something that it encourages clean code and the use of intention revealing names and stuff like that, because when you review something, you want to be able to understand it, not just now when my colleague has explained it to me, but I want to make sure that I can understand this months or years in the future. But again, try to get as much of your coding convention into some static analysis tool, so you don't need to argue about this and take up time to read and comment on this manually. In our case, to handle this in our team, the how wrong does it have to be question, we have different levels of defects we have configured the code review tool. So when I create something as a bug, I can mark it, okay, this is a defect, this is something you have to fix before you're allowed to push it to the master. Or, well, this is something that could be improved. Please refactor this, but it's okay to push it first if there's something, some deadline or so, but try to, well, some performance optimization, improve the documentation, things like that. And another level is, well, this is a question. It might be that I'm not understanding things, but it could also be some bug here that maybe it's you that have misunderstood something. So there's also something to handle different opinions within the team. I do recommend that you do the reviews before you push or merge your feature branch or whatever your process looks like. So I think that code that's available and affecting everyone else on the team, it should have been reviewed, as well as it should be compiling and statically analyzed and so on and so forth. So what you have together, it should be good code, so to speak. I think that you should consider reviewing test cases before you're doing the implementation. It's not always applicable, but it depends a little bit on what kind of feature you're implementing and what level you're working on. If you're doing some low-level implementation and working test-driven, then of course your tests will change also. So you will create new tests and remove old ones and so on. And it's not really worth spending the time reviewing all the so to speak, the low-level tests. But if you can create some high-level system test or integration test to demonstrate the feature, then by all means have someone review it before you actually get to the implementation, so you are implementing the correct thing. In the context of that, something to discuss within the team is, should the reviewer compare to the specification or the requirements, or should they just check the technical aspects of it? Of course, it takes a lot more time to actually compare to the requirements, but on the other hand, it can also uncover a lot more conceptual defects. Something to think about is that you should adjust the levels of your comments to who you are reviewing. So the guy you hired last week, you may not be as detailed or as nagging as you are with your colleague of 10 years. So you need to, in the junior teammate cases, you may focus on the big stuff that are really wrong, but your colleague for 10 years, he might really appreciate it if you point out the little things. Well, you could have optimized this one, you could have used this non-synchronized version of blah, blah, blah to improve performance and so on. One challenge when doing code reviews is to find bite-sized pieces. As I mentioned earlier, the recommendation is to review between 200 and 400 lines of code per occasion. And a while back, I did some statistics from our code review tool, and an average review of ours was 500 lines of code. And it's not really ideal either to take this 500 lines of code and then after 400 lines or 1 hour, then stop and do something else until the next day and then continue. So you need to find some way to not have such huge amounts of code to review at a time, but try to break down the issues to smaller parts. So this is a part of this feature that I think is done, so let's have this reviewed while I continue working on the other parts. Another challenge is refactorings. So if you're moving stuff around, it's easy to have a reviewer review the same code over again. So you took this 400 lines of code and moved it from one class to another, and there were only 2 lines changed. Well, then he read the other 398 lines. There weren't any changes in there. So what you should try to do, my recommendation in that case, is if you can foresee the refactorings, then first move the code, and without any changes to the implementation, commit it and then exclude that commit from the review. And then you do the change, those 2 lines of code that were changed, and then ask someone to review only the changes. And in all of this, remember to focus on the target to create a good product with as high quality as possible. Yes. So wrapping up, I will mention some different personality types that you may run into while doing code reviews in your team. And you should remember here that the same personality types can appear in multiple personality types can appear in the same person, including myself. So first of all, we have the dictator. And this is the reviewer that thinks that everything has to be done exactly his way. So he's not satisfied until the code looks exactly as if he wrote it himself. And what needs to be remembered here is that we have to allow some freedom, otherwise we will just kill the creativity and the job satisfaction within our team. Next up we have the bully, and this is the reviewer that just focuses on how bad the code is and complains about everything. And something to remember here is that while reviewing code, we should also give encouragement. Wow, this was a really nice implementation. Oh, I didn't know you could do like this. Oh, you really must have improved the performance of this by a factor of this and that much. I like this code. Then we have the politician, which is the coder that tries to avoid having to change their code by arguing instead. And in that case, we need, again, some strategy that decides how wrong does something need to be in order to have to be changed before you are allowed to pass through the process. And there are our different levels of you have to fix this now, it's okay to refactor, and so on. Then we have the procrastinator, also known as the loafer. And this is the coder that avoids making any changes until you are past deadline. So, and then suddenly you're past deadline and, well, we have to ship this. And once it's shipped, then he says, well, it's in production. Let's not touch that. It's already in production, right? So this is one of the reasons why I suggest that you do the reviews before the changes are made available to the rest of the team. So what's in there is actually reviewed and accepted in the review process. Next up we have Wild Bill. This is the loose cannon that's shooting wildly, and there's change after change after change. And for every change he uploads to the code review system, it's a new bug introduced. Maybe some old ones fixed if you're lucky, but it's getting messy and messy. And sometimes I've seen people needing like 9 or 10 tries to get that single thing right. And the virtue here, of course, is patience. Next up, we have the smuggler. And this is the person, the coder, that even though you have decided to use code reviews, he will sneak in some changes and not upload them to the code review system. And in this case, you should think about those 55% of one-line changes that were wrong. Oh, this is just a small change. I don't need to review this. Maybe you do. Next, we have the spoiled child that just writes something, doesn't bother testing, doesn't bother about unit tests and so on, just uploads it and let the reviewer find some maybe very obvious problems. So a recommendation in this case is for the reviewer to ask some leading questions like, does it compile? Does the unit test pass? Have you tested this yourself? Are you sure it worked when you clicked that button? And so on. And then let the coder fix things before you do the actual in-depth review of things. Next we have the exalted one. And this is the person in the team that for some reason is excluded from the review process. Maybe it's the senior person that's been in the team for so many years, so, oh, he probably doesn't do any errors. And the problem is that since he is excluded from the code review, then he is the one that's most likely to have bugs that make it all the way to production. Again, think about the 55% one-liners, and then maybe some other time you can ask me why you should not deploy to production the night before your wife goes into labor and you go giving birth to your first child. Anyway, then we have the dumper. And this is the coder that collects massive amounts of code, probably shortly before some deadline, and then uploads it all. And it's just impossible to get an overview of all this code. And you can't get through and actually make something out of it, something meaningful. So what you should aim for is, that I mentioned, try to do some kind of incremental reviews. Well, first, try to implement the data access layer of this feature, and then have me review that, and then you can continue working on the layers above. Last but not least, we have the unfair, and this is the person that's judging the code depending on who is the author of the code. So he has different criteria depending on who is asking you to review things. And sometimes I wish that there were code review tools that would allow you to anonymize who is the author. Maybe you could come up with some phony names when you're logging into your code review system, so the other team members don't actually know who wrote things, just to make it equal. But on the other hand, we talked about the checklist earlier that you could use. And some people, there's something called the personal software process for how you can develop as a developer. They recommend that you keep a personal checklist of 15 to 20 items. These are the things that I need to practice on. So maybe you should take your personal 15-item checklist and give to your reviewers, hey, when reviewing my code, please make sure to check these things a little bit extra.
Time's up.
Yes. Time's up.
Regarding the unfair review, you said earlier that you actually should be unfair because if it's a new junior programmer, you should review in a different way than you do if it's a senior.
Yes.
I agree with that.
Yes. You should.
You should be unfair in a fair way.
Yes, exactly. You shouldn't be judgmental. Sometimes you think, oh, it's that person, and he usually makes mistakes with these things, so therefore I should comment some extra on that. But you should be fair in that way. You should still keep the same level of things that has to be changed, while you can do your senior colleagues the favor of pointing out potential improvements that doesn't have to be changed. Yes. So on my blog you can find links to some different code review tools to get you started with tool-assisted reviewing. So any more questions before we are actually minus of time? We can take it later during the coffee break.